So much of our effort in teaching computers how to think like humans has been devoted to trying to teach them, the logical syllogisms that I was just talking about before this video. There's another kind of reasoning, which is called inductive reasoning, and it's going to be based on experience, knowledge of what's likely, and it can really lead to errors, right? And so that's something that we've been trying to teach machines also, is how to use their experience, how they can use their wide database of knowledge to figure out, to predict what's likely to come next. What's popping into my mind on the knowledge of what is likely is my my texting keyboard. I use the Google keyboard for that, and it makes guesses about what word I'm trying to type, and sometimes it'll make an incorrect guess, but what I've gotten in the habit of doing is looking at my text before just hitting send, because you can oftentimes will send out just garbage when you just hit send. But I've noticed that if I go back and it's auto-filled a word that I didn't mean to be, and I hit that word, now that it sees my whole sentence, it oftentimes auto-corrects to the word I meant, because it's using its past experience to predict what I'm likely to be typing in on the fly. But now that it's seen the whole thing, it uses its knowledge base of what's likely to have been intended to be in that spot to fill in with the correct word. So computers and computing systems have gotten really super sophisticated with their inductive reasoning. You were at that level of sophistication when you were like between probably 3 and 7 years old. You got to the level that my Google keyboard can do. The human inductive reasoning capabilities are far superior to anything the machines can really do at this point. But even with our far superior inductive reasoning skills, we can display a lot of errors, and our errors tend to come from the representativeness heuristic, right? Because we use our experience, we use our knowledge of the prototypical case and things like that. So we may display the representativeness heuristic, and then also the availability heuristic will come into play, where we say, well, if I thought of it really easily, it must be because it's really common. And so we make an incorrect guess about the likelihood of something. So we're not perfect, but we are, really vastly superior to, even the computing machines that are available. Now, I thought I'd finish up not just these two combined chapters that I sort of put together, but also the whole class with this overall theme that we've been following throughout class of this top-down versus bottom-up processing issue. And, when you talk about deductive reasoning and inductive reasoning, they fit into that same kind of model, that one of them's top down and one of them's bottom up. And it turns out that deductive reasoning is much more bottom up, using the elements that are present in the problem to help us to figure out the solution to the problem. Inductive reasoning is based on our experience and our knowledge base, so that's going to be the top down process. So hopefully an overarching theme for this whole class was this idea that, we collect elements using bottom-up, sensations and whatever to try and help us to, remember things, store things, find things, solve problems. And then we use our top-down, processes to solve problems, to store information, to do, virtually everything based on our past experience and our previous knowledge. So, well, that concludes my course on cognitive psychology. Hopefully you enjoyed listening to my lectures and found them interesting and enjoyed my Audubon clock in the background. And hopefully I'll see you guys in another class in the future. Alrighty, take care.